Exercise 4e is all about cubic functions and sign diagrams. Now I don't really use sign diagrams, but I'll explain my way around having to do them for cubics and quartics and things like that. So a cubic graph over the domain x is an element of all reals can have 1, 2, 3 axes intercepts. So it's always got at least one. Turning points do not occur symmetrically between consecutive x-axis intercepts like quadratics. What's that saying? Basically it means that if you've got an x-intercept there and there, the turning point here, although it looks like it, is not perfectly in the middle of these 2 points. So it usually leads either one way or the other, leans closer to either this point or leans closer to this point. Can be hard to tell, sometimes I get it wrong. Right, so if a cubic graph has a turning point on the x-axis, this corresponds to a repeated factor. And mathematically, quite incorrectly, I say it bounces. Okay, so that's the way I think about it, is it bounces. So here we've got a repeated factor. So I imagine it coming up, bouncing off there and continuing. Okay, so it can bounce, hit it and come back down, or it can come down, bounce and come back up again. Right, and the way that looks like in the factorization is like that, x plus 1 all squared. Some cubic graphs may look like they have a stationary point of inflection, but it actually may not be stationary, okay, i.e. it will be a point of inflection. And I wrote this one back in 2018 for the 1-2 methods test, and it was based on something that happened in a 3-4 exam. I can't remember what year it was, but it was a cubic function that looked something like this. And what happened was that I can't remember how it all unfolded, but many students found the derivative, let the derivative equal to 0 to find where the stationary point was, and found that they couldn't find a stationary point, and that's because this was a point of inflection, not a stationary point of inflection. So the question I wrote said, is -2, -1 a stationary point of the graph g of x? Justify your answer mathematically. So what we did in class was we found g dash x, the gradient function, which was -3x squared, take 12x, take 13. And then what we did was we slammed in g dash -2. So we put -2 into the gradient function. We're basically saying, hey, gradient function, can you tell me what your gradient is at x is equal to -2? So let's try it out. -2 squared plus, what's that going to be, 24, take 13. This one here is going to be -12 plus 24, take 13. And that, unfortunately, is -1, which means that it's not a stationary point. Okay, so what we're going to say is g dash -2 is not equal to 0, therefore not a stationary point of inflection, but rather a point of inflection. So if you can have a look at the graph here, what it does, it kind of comes in, looks like it's almost going to go stationary, but doesn't go 0 gradient. It actually, the lowest it gets to is -1. So it gets to a gradient of -1, and then the gradient starts to, what's the word for it? Should I say go more negative? Yeah, go more negative. Okay, these are some cubic function shapes, so that's just a little bit of a variety of what you might get. And again, this one here is the one that looks like it's got a stationary point of inflection, but it in fact does not have any stationary points on it. Okay, still cubic. Alright, so sketch this thing here. So what we'll do is we'll use the remainder theorem to find a linear factor. So we're going to go f of 1 equals 1, take away 2, take away 1 plus 2, and we've already hit a winner. Okay, so the conclusion is x take 1 is a factor. Okay, so again, you can use whatever technique you want to factorize this. I'm going to equate coefficients. So f of x equals x take 1 multiplied by, that one's going to be x squared, that one's going to be -2, and this one we don't know yet. Alright, let's get our x terms by going -b, take 2 equals the coefficient over here, which is -1, -b equals, 1, b equals -1. So f of x equals x take 1, x squared take x take 2, x2 1, that's the negative. F of x equals x take 1, x take 2, x plus 1. X plus 1. Alright, so what we want to do is let f of x equal 0, x take 1, x take 2, x plus 1, and apply the null factor law, x equals 1, x equals 2, x equals -1. Alright, let's sketch this thing. No, not an asymptote. A Cartesian plane. So let's go solid. And there. Alrighty. So we've got -1 there, 1 there, and 2 there. My y-intercept is +2, so somewhere up there. So don't need a sign diagram for this. So this is a Pos Cubic, so a positive cubic function. And we're going to note that positive cubic functions start with a Pos gradient. So they always start with a positive gradient like that. So as you start to draw them, basically it's going to go up, down, and then back through again. Now remember, it does not turn on this point here 2, when x is 0, y is 2. It doesn't turn there. So what it will probably do is turn before it, swing back down, and come through. It may turn after it. I'm not 100% sure, and without sort of some differential calculus, I won't be able to work it out. So I'm just going to assume it turns beforehand. Right, so here it goes. Okay, not too bad. -1, 0, 1, 0, 2, 0, 0, 2, x-axis there, y-axis there. Alright, let's find out where it does turn. So to actually work it out, I'm just going to quickly graph it on Geogebra. Probably should do it on my calculator, but just prefer using Geogebra if I can. Take 2x squared, take x plus 2. Yeah, so you can see there that it turns marginally before that. That's a bit of a fluke there. Don't really know. Didn't really know whether it did or it didn't. It felt weird, like I was going to have to turn too hard if it turned afterwards down to hit through the 1. But yeah, just need to know that it doesn't turn at the midpoint. Right, hence sketch 2f of x, f of x take 2, and negative f of x plus 3. Alright, so let's draw 3 Cartesian planes. And that one. Okay, 2f of x. Alright, so the original function, so this here is a dilation factor 2 from the x-axis. So it'll look pretty much the same, except the y-intercept is going to go to 0, 4. And what it will do is just stretch out a bit from the x-axis. So I'm just going to change it to a 4, -1, 1, and 2. So same sort of look and feel, except it goes like that. Okay, so -1, 0, 1, 0, 2, 0, x-axis, y-axis, 0, 4. Right, so let's just try that on Geogebra. Okay, so 2f of x. And you can see there what it does, just stretches out or multiplies all the y values by 2. Right, this one here is a translation 2 units to the right. So what's going to happen is this intercept here will go 2 units over, so that's going to be at 1. This one's going to be 2 units over at 3. There's 2, there's 3, and this one 2 units over, which is 4. Right, so what's going to happen is it's going to come up through the y-intercept, go through there and up through there. So let's try it out. Alright, so there it is there. X, Y, 1, 0, 3, 0, and 4, 0. To get the y-intercept, we'd have to actually bang x take 2 into the function and do a solve on that. So I'm not going to do that. It's not really the point of these questions here. So let's just see if Geogebra will tell us. I don't know whether it's a clean intercept or not. What are we doing? F of x take 2. And h of 0, please. Negative 12. Alright, so let's just pretend that we did that on the calculator. We did that by hand, subbed x take 2 in, let x equal 0, and it would have told us that the y-intercept was when x is 0, y is negative 12. Alright, the last one. So this one here, what that will do is flip it, and then we're going to add 3 to it, so send it upwards. So what would actually happen is this is negative 1, 1, and 2. So what would happen is it's going to go like, it'll come down like this, right, where that is 0, negative 2. Right, and then it's going to go up 3 units. So that is going to pull everything up 3 units. So negative 1, 0, negative 1. So it'll be like there at 1. Right, so what's going to happen is that it's going to come down like this, back through, and go somewhere like that. Not sure what the x-intercept is. Again, I'd have to do this and get the x-intercepts when y is equal to 0 to actually get it. We're not, again, really worried about that. All we're interested in really is, do I know what it's going to kind of look like after the transformation? That's the skill. All right, here's a couple more to sketch. Okay, this one is an inflected cubic. It's moved 2 to the right and 1 unit up. So there's the stationary point of inflection. It's going to sort of come up, inflect, and go back up again. So the x-intercept's going to be there. I'm not going to, I think actually the x-intercept is 1, negative 1, negative 1 plus 2. Yeah, it is at 1. All right, so let's label that 2, 1, x, y. When x is 0, y is 1. Right, this one here, let's do that one. So it's going to be 2, 1, there's negative 1, negative 2, negative 3, about there. Right, the y-intercept is going to be negative 2, 2, 6, somewhere up there. All right, let's do it. X, y, 0, 6, negative 3, 0, 1, 0, and 2, 0. All right, the last one is that, so it's 2 and it's negative 2, and the y-intercept 0 to 4, 4 2s are 8, somewhere up there. Alright, now what's going to happen first of all is that is your repeated factor is here. So it's got to come up through there and bounce there. So 2, 0, didn't even get close. Get rid of that, destroy all evidence. Right there. So that's negative 2, 0, and 0, 8, x and y. Alright, so that's all there is to it for 4E. Now let's just jump into graphing polynomials of a higher degree. This was a really quick one we did in class. So there's 4 graph sketches here. Again, it's supposed to be pretty rough ones just to sort of get an idea of what they look like. Right, so this one is an inflected quartic. So quartics look like that. And we need to know that Pos quartics start with neg gradients. We don't need a sign diagram. Okay, so here is the basic parabola, an upright parabola. Notice that it starts with a negative gradient. Right, so all power or even power polynomials will start with a negative gradient. All right, so let's graph this thing. So we've got 2 to the right and 1 down. So there's its turning point. What is the intercepts? I'm just going to quickly do that. 1 plus or minus 3 and 2. So it's going to go through there and swing up through a y-intercept up here somewhere. Y-intercept is going to be 0, 16, 15. I'm not going to do that. It's not going to work out to scale. So I'm just going to pretend somewhere up there. Down it comes. Well, that's not bad. 0, 3, no, is 3, 0, 2, negative 1, 1, 0, and yeah, we'll just leave the y-intercept for the moment on that one. This is the x, this is the y. All right, the next one is one with 4 intercepts. Okay, so we've got 3, 1, negative 1, and negative 2, x, y. Let's do a quick one on this. So negative 3 times 1 is 3, 3, 6, somewhere up here. Okay, so what's going to happen is that positive quartics start with a negative gradient. So it's going to start and it's going to come through these points, up through there, back down, back up again. Right, this is going to be difficult to draw the y-intercept all the way up there. It's a bit silly. Let's put it down a bit lower. 6. Okay, all right, let's see how this goes. All right, 3, 0, 1, 0, negative 1, 0, negative 2, 0, 0, 6. All right, now this one here, so note the repeated factor here. It's repeated 3 times, which means that that is actually an inflection point. Okay, so it inflects at 2. It's got another one. There's 1, 0, negative 1 around about there. Y-intercept negative 8, 7 down here, negative 7. All right, so it's positive, so it starts with a negative gradient, so it's going to come down through the y-intercept and inflect there. Let's see how it goes. Not really. Well, that's nice. All right, the last one. All right, so note that what that negative will do is give us this is a negative quartic, so we just need to adjust the graph accordingly. Okay, so we've got negative 1, 0, and this one is going to be negative x plus 3 equals 0, negative x equals negative 3, x equals 3. So there's 1, 2, 3, somewhere there. The y-intercept, when x is equal to 0, of course, this is the repeated factor, so it bounces there. So the x-intercept is also the y-intercept. Alrighty, so because it's a negative quartic, it's going to start with a positive gradient. So it's going to go up, down, back through again. All right, so there's 4F. Get it done.